Yes, last time I think I forgot to record the lecture, but I found a similar one in the previous semester, so I still will post the one. It's not exactly same as what I talked about last Thursday, but it's a similar content. Okay,
I want to apologize about last Thursday. I ended up having an appointment I had to go to. I apologize.
Okay, so I have videos, so please watch the videos. Last time we derived the force on the, how to calculate the force on the plane surface under in the fluid. Okay, plane surface force in the we'll find the location where the combined force applied to, you know, for the purpose of drawing a free body diagram. So you need to put the arrow pointed to a certain location, right? It's a combined force. It's a distributed force. You have to use the combined force in the free body diagram to solve problem. So that's what we didn't put in, give any examples. I just go through that derivation on the textbook. Okay, so today let's look at one examples. Okay, I want everybody to turn on the camera. We will have another quiz during the example I give you. Okay, so it's also a small 2-point quiz just to see if you follow the instruction. Okay, so see, I feel everybody should get a good grade for this semester because we have so many quiz opportunities, and basically is just to how to say, if you sitting there, listen carefully, follow the instruction, we should do well on those quizzes. Okay, so that's my plan. Okay, let me share my screen. That's where we were last time, right? Let's do a quick review here. So we derived, although my drawing is terrible, but the drawing is in the textbook. Please, you can refer to the drawing in the textbook. Okay, so that's the derivation we did last time to find out the equation for the overall force on a plane surface. Okay, so we turn out to be,
Zhang,
yes.
I like that. Would you could you use like a drawing pad to do your writing onto it?
Yeah, I think this is the drawing pad, but the problem is the computer here I'm having, the screen is upward. I cannot lay it down. So
that's what I'm talking about. I work up here with Sawyer, and they have little pads that you plug into your computer.
Oh, okay.
That you can write on.
Oh, that's great. I talk with Sawyer. Yeah.
Okay.
Actually, I ordered a new computer. I hope the new computer helps. I ordered a Surface. The Surface had the the pad, something.
Yes, sir. I just want to ask
that yeah, good point. But I don't know how long it takes for them to give me to order the purchase that
they have it here. They have them here right now.
What do you mean?
They have the little right here, Dr. Merchant. They have them actually up here with Sawyer right now. They have a couple up here.
Oh no, but I actually ordered a new computer.
Oh, the Surface
from the grant. So
okay.
So I don't know how long it take for them to send me the computer, but it will be here. I think. Yeah, I talk with Sawyer.
Okay.
Yeah, that would be great helpful. For helping my drawing. My writing and drawing is pretty difficult right now on a vertical screen. So yeah. Okay, that's what we were last time. We turned out to find out that the overall force on a plane surface. Yes.
There are some teachers that don't even share their screen at all for upper level engineering courses. So I think you're doing a really good job.
Okay, thank you. Okay, thank you. I kind of get used to the virtual learning like this and try to, try to give you a best experience I can, as similar as face-to-face. Basically, that's my my goal and what I try to do. Okay, so it turned out to be the force equals to, I think it's pretty common sense, right? The force equals to average pressure times the area of the surface. Right, this part I think everybody agree. Basically, it's just average pressure times area. Okay, because the pressure is not a constant on the surface, so have to find the average pressure. So the next goal is, hey, what is average pressure on a plane surface? Okay, it turned out to be from the derivation. It turned out to be that average pressure happens to be the pressure on the centroid location of the the surface. Okay, so the average pressure is the pressure on the center of the area of the surface. Okay, so that's what it's a derivation about. So how do you find the center pressure? You have to identify the centroid or center of area of the surface. Okay, so in any problem related to the plane surface, you have to know where is the center of the area. Okay, if you know the location of the center of the area, you should be able to find the water depths or liquid fluid depths on top of the centroid. Okay, so use the water depths on the centroid to calculate the pressure on the centroid, gamma times H. Okay, so we use H bar here to represent the water depths on the centroid, right? We use Y bar to represent the center location along the coordinates, along the Y coordinates. Be careful, Y coordinates is start from the surface of the water along the direction of the plane, and this is the Y coordinates. Okay, so Y bar is the centroid, the distance between centroid to the water surface along Y direction. Okay, be careful. Some of the letters here is a little confusing. I understand. Okay, so be careful on that. Okay, so that's the process. Everybody on the same page with me? Is that good? To calculate the force value on the surface. Just find out the central location. Measure the water depths on the central location. Okay, so or maybe calculate the water depths on the central location. It needs some geometry here, trigonometry. Okay, in some of the problem you will see. Okay, so okay, so this is the force. Then we have an example here. Then this is the force location. It's a distributed force. So if you want to use one combined force to represent the distributed force in the free body diagram, you need to know where is this combined force applied to. Okay, where you draw this arrow pointed to the location. That location, okay, that point, that location we talked about in the class, that it has to be lower than the centroid. Okay, we talk about that. Okay, because it has to be balanced. All the force has to be balanced about this location. Okay, so it has to be lower than the centroid. So in any problem I ask you to do, if you want to draw a free body diagram, make sure you clearly mark the centroid location, and then make sure your arrow is pointed to a location lower than the centroid. Otherwise, I will take point off. Okay, because it has to be lower than the centroid. So centroid location is your reference point in the drawing. Okay, you have to point, everybody, please listen carefully on this. Okay, you have to point your arrow beneath the central location to a location that beneath the central location. Okay. Okay. Maybe in today's quiz, you probably need to do that, right? Okay. So, and that location, we define that location between that point to the water surface along Y direction. We say it's called YCP. Okay. YCP stands for what? Chris Paul? No. Is he still playing?
Yeah,
Last time I checked, he's in LA, right? LA Clipper is still there?
Nah, he played for the Suns now.
Oh, really? He played for the Sun now. Okay.
Yeah, he played with
Phoenix Suns.
Okay. He's a good player. He's a good player, but he's not a championship type of player to me. But he's a good player. We fortunate to have it here in Louisiana for how many years? 3-4 years. You know. But anyway, center of pressure. Oh, 4 years. 4 years. Yeah. YCP, center of pressure. Okay. Remember, it's not the vertical distance to the water. Okay. It is from that point to the water surface along Y direction. Also, it is not the distance between that point to the beginning of the plate. Okay. A lot of actual problem when students solve, they will confused about the distance. They think the distance between the point to the beginning of the plane is the YCP. No, it's not. YCP, by definition, is from that point to the water surface along this y direction. Okay, so be careful. Small mistakes then will lead to wrong answer, right? So be careful on that. So we have an expression, equation for YCP, which is this, okay? Y bar is the centroid location to the surface along the coordinates, okay? A is the area, and I is the moment of inertia, right? So, but the expression for I is on the appendix of the textbook. I think I sent you, did I send you the picture of that appendix in GroupMe? I remember I did, let me double check. Yeah, I think I did last time, okay? So basically in the appendix, there are 6 common shapes. It gives you the expression for the I bar, the moment of inertia for all these 6 shapes. You need to practice, know how to use this table, okay? Practice some homework problem. I will assign homework problem after today's class, so please practice some, okay, using this table, okay? So follow the dimensions on the table for those equations. And also in that table also shows the centroid location, the exactly location for the centroid for each of the 6 shapes, okay?
I can't read what the words on the bottom or what the first words on the bottom are. Do we need those formulas, or we just need the pictures with the measurements?
You mean the appendix I send you?
Yeah. Do we need the bottom part or just the top? The
Okay, let me see let me see what is the bottom part. Bottom part is bottom part is for your benefit. It's area in the volume, okay? For the shapes like this, if you need to calculate the area, for example, if you want to calculate the area of a ellipse, okay? So what is the area? Is that right? No, it's just a circle. Area. I think the area is also listed in the table itself. The bottom one is what? The volume and the area formula for what? For the sphere, for the cone, and for the circle. Okay, that's for other purpose. It's not for this purpose. Okay, but the 6 figures and the equation associated with the 6 shapes, these are the good information. Okay.
Okay, thank
you. You're welcome. Okay, so let's practice it. Let's use an example to practice how to solve problem with these theories. Okay, so I think we have a example. Let me start from a new page. Okay, this is page number 9, so only 1 page left. Let's create a new document. 10-page. Okay, do you see the blank page? Okay, good. Okay, let me turn my light. Okay, the example is, actually that example is not easy. Let me tell you, this example is pretty comprehensive to me, okay? So is example 3.10. Okay, number 3.10. Let me draw this thing. So you have a reservoir here. You have actually a pipe, okay, to let the water coming out. And it has a gate. It's a circular pipe with diameter 4 meters. Okay, with diameter 4 meters. But it cut it like this with the angle. So what is the shape of the gate? Okay, this is the gate. Gate is hinged on the top of the pipe. Okay, so water depths, let's see. This is the water, the depths between the top of the water surface to the top of the pipe, it's a meter. Okay. So it says the longer length of the gate here is 5 meters. So I think that's all the dimensions. Okay, all the dimensions. Okay, so let me ask you this. What's the shape of, I cannot draw, you know, this is 3D things, right? It's hard to draw on each angle. So what is the shape of the gate here?
Would it be a an oval?
Yeah, it be the oval, right? I think I agree. It would be like this, okay? So what is this design? Is this design, how this design works? Okay, so you have a gate hinge here. It's a circular pipe. But when you cut a circular pipe with an angle, the cross section become a oval, right? Oval shape, elliptical shape. Okay, is that right? Everybody agree? Okay, so the gate is here. How does this gate, the hinge is here on the top, okay? So the gate will open this way, right? So how does it work? So you need a force to open it, right? Without applying a force, the gate will fully closed. Do you agree? That's why we cut it like with the angle. It's never gonna go inward. It's a circular pipe. If you cut like this, put a gate down there, it never can go inward. So automatically it will stop. It will close the gate. Okay. So
It's a check valve.
Yeah, just like a check valve. You're right. Okay. It never will open. Okay. Because of the water pressure on it, it will keep closed. But if you want to open it to let the water coming out through the pipe, you have to apply a force to it. Okay. To make it open. Okay. Is that right? Okay. So this is the problem. Problem will ask you to calculate what's the force required to open this gate. Okay, very practical problem, right? You need to make sure, okay, I'm able to open it. So I need to calculate the force. If it turns out to be 3 million pounds, forget about it. I'm not gonna open it, right? So that's why an engineer we do some calculation before we actually do the action, right? Okay, so how do we solve this problem? Okay, so what is the first step?
On the centroid.
Okay, so let's do this. First step, yes, you probably find a central, sure. But first step is to draw the free body diagram. Okay, before you can actually write down the equation. Okay, so let's do the quiz here. It's very easy. I want everybody get 100% of these points. Okay, can you draw the free body diagram of this gate? I want you to do this. Okay, I want you to complete the information. Okay, let me draw the gate for you. Let's say the gate is, you know, it's just a 2D view from here, on the side. Okay, it's a gate. Draw this gate. Okay, so I think the first step is to, you know, when you detach the gate, you need to represent a force, right? So you detach the gate from the hinge. Let me give you the force here, which is will not be used anyway in this problem. So this is the supporting force, Rx, Ry, right? I want you to write it on your paper. Next time, maybe in other problem it needed. So, but in this problem, probably you don't, okay? So Rx, Ry, you know what I say, right? I want you to draw on the paper, they're representing the hinge. Now you draw the free body diagram. Obviously, you want to draw the free body diagram of this gate for this problem, right? I think this is, of course, the first choice. So the gate, you draw the gate here, side view, okay? You detach the gate from the pipe wall. Anytime you do that, okay, you detach it, basically. You're not drawing the pipe, so that means you detach it, okay? You just draw the gate. Then you have to replace the support, which is the hinge, by the two forces. Hinge stop you from go this way and go that way. So this is, you can put arbitrary Rx and Ry. Okay, I stop here. I want you to draw everything else, arrows. Give each arrow a name using letters, which will be, you will use the letter later in the equation, okay? And I want you to write down all the dimensions that needed for the calculation, okay? So what is the length? Use some letters representing the length which will be needed in your equation, okay? Then I think just want you to write all the letters that needed for the equation, okay? All the dimensions, okay? Then all the forces, okay, with the name for each forces, okay? All the dimensions. Then after that, you pick a equation for this. I give you a hint here, equation. Do you want to use the force balance equation or moment balance equation for this problem?
Moment.
Why you pick the moment? Is there's some reason, right? Well, and the next time you see a new problem, can you make the same decision, moment equation or force balance equation you want to use?
Being rotated.
That's right. That's right. And I just looking for that word, rotation. Okay. This problem, the movement, intended movement is a rotation, not pushing it or not, pulling it. It's a rotation. You have a hinge here. If the problem is rotational problem, then likely, not 100%, but likely you are going to start with a moment balance equation. Okay, so moment balance. So you probably want to start the equation like this. I write it down. I just want you to extend it. Summation of moment about a pivot point equal to 0. That's a moment balance equation. Let me draw the pivot point O for you. Where's the pivot point? So if you want to use a moment equation, you need to identify the pivot point in your drawing. Otherwise, I'm going to take point off too. It's not moment about any point, right? Where's the pivot here?
At the hinge.
It's a hinge. Okay, so write down O. Whatever letter you want to say, A or B. Usually I use O for the pivot. Okay, so summation of moment about O equals 0. Okay, now I draw the O on the hinge here in the free body diagram. So complete the free body diagram and expand this summation of moment about O equation. Just one equation, just expand it. Okay, using all the letters you put it on the drawing. That's it. Then submit. Take a picture, submit. Just one line. You need to draw it and plus one line of equation. Okay. No need for any calculation. Quickly. I think 2-3 minutes you should be done. Okay. Go ahead. And the summation is already open on Moodle, so just take a picture and submit it. Let me give you 5 minutes. Okay. 9:55 now to 10 o'clock. I will continue, and the summation will be closed on 10. I want you to use letter. I don't want you to put any number there. I want you to be consistent, your equation and the letter you used in the free body diagram, okay? Okay, and turn on your video, it's a quiz. Hey, please turn on your mic. Turn off your mic, I'm sorry. There's some noise down in the background. Everybody's writing now, doing quiz. Please be quiet. just carefully draw it. Don't miss anything. Don't miss any force. Don't miss any dimensions, you know, and put the letters. Okay, then use those force and dimensions to complete that equation. One line.
On the equation, after we draw the free body diagram, do you want us to use the units as well?
I don't want you to use any number. I don't know what you mean by unit. And
All right.
just reuse the letter. You
Yes, sir.
put it on the free body diagram, okay, to
Yes, sir.
expand this summation moment equal to 0 equation. Yeah. I'll give you a little bit more time. If is anybody done? Need 2-3 more minutes, right? Okay. Good. How many of you have done? Okay, if you look at the screen, that means you're done, right? Okay, good. Okay, let's close the let's close the. I will give you the exactly answer, and let's close the summation. Start from now, 10:01. If you haven't submitted, then I won't accept it anymore. Okay, so okay, so forces. You have two forces. The point I wanna I want to see on the drawing is this. I want to see, just like I said, I want to see you mark the centroid. Use a cross or use a dot, whatever. Okay, that will be point. If you don't have this central location, I'm gonna take some point off. Okay, then I want you to see you draw this force. This is the hydrostatic force from the water. Combine the force from water. Okay, put a name to it, FH. Okay.
PF.
What did you say?
I put PF. That's good.
That's fine. Doesn't matter. Name whatever name you put it, as long as it be consistent the name you use in the drawing and using the equation. Okay, doesn't matter. I use FH. You want to use something else? That's fine. And some other force. For the force required to open it, it's already in the initial problem statement drawing, right? So that's the force needed to open it. It has to be at the end. Do you know by chance know why you want to open the gate at the end?
Requires least work that way.
Require not least work, require the least, yeah, require least force basically, right? Yeah, I know what you mean. So it requires least force to open it because it has the longest arm. Okay, so it's a torque or moment that matters when you open stuff, right? Open a gate. So the torque is force times the arm length. So it's if the arm length is the longest, then the force is the smallest. Okay. So
that's actually 0 right now. It says atmospheric pressure on the other side, so that force would actually be 0.
What do you mean by atmospheric pressure? It's not. It's underwater.
The picture in the book shows the pipe. Maybe I'm looking.
But the pipe in the left side of the gate is exposed to the water, right? So the water apply a tremendous amount of force to the gate.
Yeah, I'm talking about the one pushing the other way towards the.
So if you want to push it open, you have to overcome the water force. So it's not atmospheric pressure or 0, right? So that's the force you need to apply on it, the gate, to make it open. Is that right? Is there any confusion here? Josh, right?
I was confused on that as well, kind of what
Okay.
Josh said.
Yeah, I understand that's what it is, but I'm looking at the picture in the book, and it actually says the pipe inside the pipe is at atmospheric pressure right now. So I still included that force, but that force is actually 0 if it's atmospheric pressure, right?
Yeah, you don't have to increase to 0. Yeah, yeah, sure. I understand what you mean, but if you want to include that atmospheric pressure force, then you have to add the atmospheric pressure force on the water side too. It's the force. Then in the equation, then the FH is not only the water force, but also the atmospheric pressure force on top of the water surface. You don't have to because they canceled. Okay, if you want to add on the left side, you have to add on the right side too, or mention it, the FH includes the atmospheric pressure force on the surface. Okay, so if it's okay if you add the atmospheric pressure on the other side, you have to add atmospheric on the other side too. So okay, I'll take a look at what you wrote down. Okay, but do you understand? Okay, I think 2 of you asked the same question here.
Yes, sir. I understand that.
Okay, so start for now. You can neglect the atmospheric pressure force because in our class, most of the time, that's why we introduce the gauge pressure system. When it's gauge pressure system, atmospheric pressure is 0. So you don't have a force from the atmospheric pressure. Okay, so that's the logic here behind here. Okay, so 2 forces, force need to open it and the force needed to force from the water. In dimensions, okay, I want you to write down the dimension that you will use in the moment calculation. One is this. This is a dimension, but you cannot write YCP on this dimension because YCP is from this to the surface of the water, which is very far away. This you have to use some other letters. Let's say, hey, this is L. I can go to arbitrary letter. Okay, this distance is given. It's 5 meters. It's okay. You can just write 5 meters because it's given. Okay, so that's the complete picture I want to see on your drawing. I want to see the central location reference to my water force. That means water force is below the central location. Okay, I need to know these 2 forces, FH and F. Okay, I needed to know the arm length. One is you don't know. L cannot be YCP. Okay, and the other is phi. Okay, this is what's supposed to be on the drawing. Okay, then you expanded this equation. That's easy, right? Summation of moment. Clockwise, which one is positive? Clockwise rotation or counterclockwise rotation is positive. Moment has a direction.
Clockwise rotation.
Counterclockwise is positive.
Yes,
but I
counterclockwise,
mean,
just right. Counterclockwise is positive and the clockwise is negative. Okay, so between these two forces, FH and FH, which one will create the counterclockwise rotation?
FH.
FH. So let's put FH first because it's positive. FH times L. Okay, that's what I want to look at. Minus F times the arm length is 5 meters is 0. Okay, that's it. If you write down this and draw the diagram, right, got 2 points. Okay, 2 out of 2.
Yeah. Unfortunately, I wrote YCP on there, so that's definitely wrong. But I had 5 meters. You said you didn't want any number, so I just changed 5 meters.
Yeah,
That's fine.
yeah.
That's fine. Doesn't matter. I understand. You use another letter. Let's say D. That's fine. I don't care. The number.
So like, if you have a like L representing like length, would that be fine?
Yeah, I think as long as you use a letter consistent with the equation. Okay, you write the letter down there as this 5 meter, you use the letter, let's say H. Okay, it doesn't matter. Here in the equation, the 5 meter, you have to use H. Just be consistent. Okay, as long as it's consistent, you won't lose point.
All
Okay.
right. Well, on mine, YCP just means length.
Let me take a look. I give you partial points.
Bro, I forgot it was to the surface.
Yeah,
Can we get like participation points for like actually even doing it?
Participation point.
I'm just playing.
Okay.
Give us something for attempting.
Give us something.
Because I mean, you got people absent. You know, we actually here, so.
Okay.
Yeah, that'd be nice because I screwed up on mine.
Okay. Sure, but no problem. Now, do you understand this? This is the starting point. You have to be. I emphasize it a lot in this class on the starting point for every problem. Okay. You otherwise, if your starting point is wrong, there's no hope. Okay, continuing. Okay, so that's the most important. The starting point, you get the right direction at least. Okay, rest of stuff, if you don't know how to do, hey, intern, come. I'm an engineer now. You're an intern. You do it for me. Continue. Right. So at least you're good. You're good to be a boss, basically. Okay. Okay. Now we are here. So our unknown is in the equation. Sure. Obviously, when I see this equation, I'm happy because now I'm certain I can pass this work to my intern. Okay. So go ahead, solve it. Solve for F. F is in there. Basically, what you need to find out in this equation is just FH and L. These 2 letters. Find out the value. Then you solve the problem for F. Right? Do you agree? That's why the beauty of this, write down the drawing, draw the drawing correct, write down the equation correct. Then this beauty, you're confident. Then you're in the final exam seeing this. I'm happy. This is a 25-point problem. Probably Dr. Zhang will give me 10 points of this already if I just leave. Okay, so you're happy. You get something. In the previous experience, sometimes in the final exam, I think some students never attend the class and don't know what whatsoever. So give me a blank paper or just write a couple of things down there, really irrelevant. And people get 10 points out of 100 in the final or something. I can't help to, pass the class, help you pass the class with this kind of things, right? But at least write down something. You already get points. Every problem you get 10, 15 points. You pass the final exam already. Okay, I just want to really emphasize on this. Okay, get the first couple steps right. Okay, then go to the detail. Okay, L and FH, that's your new goal now. Okay, I can't care less about the whole problem anymore. I just want to find out what is FH and L. Then I solve the problem. Okay, so I need to use the next page. Unfortunately, I need to let's, can I copy and paste this drawing on the next page so you can still see? Let me draw it again here. Okay, quickly. Okay. A meter, that's the distance. This is 4. This is 5. Okay, so our equation is FH. Can I put the signs on the drawing here? F, okay. Okay, let me do it again. So, FH, F, okay. This is L. This is phi. This is the central location, okay? So FH times L minus F times phi equals 0, okay? So our goal is to find out. Now you can separate it in the paper, say, hey, FH equals what? L equals what? So in the model engineering, everything is run by the computer, right? AI, the computer gonna solve this. What computer do is you have a couple of subroutines here to find the FH and the L. Okay, usually your main program just call the subroutine, then it will return the value to you. So if you don't know how to calculate FH and FL, you ask somebody else to write the program, write the separate subroutines. Okay, so this is how the future works. Okay, which one is more easy? I think FH is easier, right? Do you know how to calculate FH now? This is the overall force on the overall water force on the plane, right? What is FH? Write down the steps to earn points in case you did something wrong in the future, in the later part. Okay, write down something. Write down anything you know on the paper. Okay, that's always a good habit. Okay. You see, for me to grade, I can give you an extra point for write down this P bar times A. Okay, that's simple, right? Don't just try to solve it on your scratch paper. Give me a final answer. I don't care the final answer. Okay, I'm telling you, I care the steps. Okay, so P bar, right? Average pressure times the area. Do you know the area of the thing? Area. Let's say the area first. Okay, see, it's oval shape. Okay, what is the area of an oval? Okay, I think the appendix I've sent it to you.
It's pi times A times B.
So what is A and B? Is the diameter, two diameter of the oval?
It's
Radius?
It's
the
radius. Be
from
careful. Okay, the
both
equation is pi
directions.
AB, but AB are the radius. A is the vertical. I think the vertical radius. B is the shorter radius here.
Yeah, A is
Okay.
the vertical and B is the horizontal.
So set aside P bar, okay? Area, so we can definitely find pi. So what is A and B in this problem? Give me numbers. Now you need a number to put it in.
2.5 and 2.
2.5 times 2 meter square. Okay, it's good to always put the unit on the equation. Okay, so try to you can avoid some mistake in the unit conversion. Okay, good. We find out the A is basically phi pi, right? Okay. So now, what is average pressure? What did we say? Average pressure equals anybody can help me here?
It's the pressure being, it's the pressure at the point at L.
It's a pressure at the centroid. Okay, say the word center or center of area, which I marketed on the free body diagram, that point, the pressure on that particular point. Okay, that's the average pressure. Everybody agree? Everybody on the same page with me? Okay, okay. You can interrupt me any time if you just didn't follow any point, okay? So pressure on that center location, how? What do we need to find out the pressure on that center location?
What the fuck?
We just need the water depth H on that center location, okay? So is that right, everybody? What is the expression in terms of H for the center or for the pressure? Gamma times H. Remember, you have to memorize some equation. This is definitely the one you need to memorize, okay? So otherwise, in the complicated problem, you are too frustrated, okay? Any equation, I couldn't remind you to look into the equation sheet or whatever, so it's too much frustration. Remember some, memorize some equation. Gamma H, that's the one you definitely need to memorize. That's the pressure equation, gamma H. Everybody, did you remember? Okay.
I lost my internet for
okay.
a second there. I had to switch to my phone. Does that say 25 times 2?
Oh, 2.5 times 2. That's pi AB. That's the area of a oval, of a ellipse.
And that's, okay, meter squared?
Yeah, it's a meter squared. Yeah.
All right,
2.5 is the radius, radius of the oval. Okay, 2.5 and the 2, right? 4 and the 5 is the diameters. So 2.5, 2. This is the area. Okay, good. And this is the pressure on the center location. Everybody follow me? Pressure on a point. Okay, gamma H. Okay, so you might wonder, what is H? Don't worry about it. Write down on the paper gamma H, earn some point first. Okay, what if eventually you couldn't find out what the value of H? Okay, I still get some points. I'm accumulating points. Okay, by writing down the correct things. Okay, let's move it down later. Yeah. Okay, leave some space for calculating the FH. Everybody, any questions here so far? So in order to find out H, basically we narrow it down to find out what is the water depth on the centroid of this plate, the H. Is that right? That's the only unknown here, H. So what is H?
Is it YCP sine alpha, sine?
No, you don't want to go through YCP. YCP is more complicated than this. You go through a more complicated thing to find out H. That's not the way. Think again. There's a much easier way to do that, to find out H.
Would it be 10?
Would it be 10? That's a good question. Everybody?
Isn't it a little over 10?
Yes. Well, it's 8 plus half of 4 is 2, so it'd be 8 plus 2, right?
I draw this line here. This is the parallel line, right?
Would it be 10 and a half?
Between center and here, in the center of here. This should be a line horizontal to the ground. Is that right? They have the same distance? These two centroids, the same distance to the water surface? Right?
Well, isn't 2.5 the distance from the well,
no,
no
2.5 is on the distance on the plane surface, which has an angle. We are looking at the vertical distance. You see my line draw here between the two centroids. So each end and the surface will have a centroid, right? Is that right? You draw the line between the two centroids. This is the horizontal line. Is that right? Which means the distance between the two centroids to the surface are the same. Okay, that's a basic geometry, right? Okay, so in that sense, we can just find out the distance in the right side. Okay.
Oh, so you're saying the y value is for the centroid is 2 meters?
You know, I want to say this from here to the surface. What is the distance from the centroid in the right surface to the surface, to the water surface?
10.
10. It is 10. Is that also the 10 in for H? Because it's parallel. It's horizontal, right? It's the same elevation from the for the left surface of the centroid to the right surface of the centroid. They are the same elevation. Do you agree? Okay, so you only need to find out the 10 here in the right. It will be the same 10 in the left. Does that make sense, everybody? Josh?
Well, yeah, for the centroid, but what I'm thinking, don't, because you say to put the force lower than the centroid, wouldn't we have to find that distance?
Yeah. See, don't jump. We are still in this first step here to find out your FH. L, see, I put L down here. Okay, we will later. Okay, don't worry about it yet.
Okay.
Okay. Step by step. Okay, get some step right, earn some point first before you go to the next step. Okay. Is that right? Everybody agree? So this is the gamma times 10 meter times 5 pi meter square. So what is the value for the force? You can calculate it, right? What is the gamma of water? Do you remember?
Isn't it 9,800?
9,800 is
So
fine
it'd
with
be
me. 90 and 10 or 98.
98,100.
Yeah. 9,800, right? Not 98,000. 9,810. So.
No, I mean when you multiply it by 10.
Yeah. Sure. Oh, you gave me the value. That's great. 10 times 5 pi. So what is the total? Please say it again. I didn't write it down.
98,100. Is that what?
98,100, right? That's that coincident. Okay. 98,000 Newton for the force. Do we have that value? Yeah, it's exactly correct. Okay. Good. You have at least 15 out of 25 for this problem if you reach to this point. Okay, if you reach to this point, 15. So 15 of each problem. You think about final exam, 4 problems, 15 each. Then you already got a 60. Okay, already is a passing grade. Okay.
The
So
total answer is 98,100.
Yeah,
Oh
98,000.
no, that's just gamma H.
That's just gamma H.
No. This is FH.
No, the 98,100 is just the
98
gamma H.
No,
Yeah, that's not what I'm
gamma
getting
is
for the final answer.
9,800. The final answer is 98,000. In the textbook, it says 98,000. I think. Is that
I'm
98,000?
getting 1,539,380.
Oh, okay.
Yeah,
So
because
you're
gamma
right.
is 9810. You multiply that by 10, you got 98,000. You still got
5 pi to
5
go. Yeah.
5 pi.
So that's nothing 98,000. Okay. So what is
Yeah,
the
I can't
value?
do that. I can't do that one in my head.
So what is the value? 1 million, 1.5?
1538600.
Okay. 1540000. Let's just do this. Okay. It doesn't matter that accurate. I think the book says 1.54 million Newton. Okay. Okay, so we're halfway through. So see, we'll come back to the initial equation. We're happy, right? We have FH calculated. Only thing left is the L. Okay, so what is the L? Okay, L is the most sticky point for this problem. Okay, we leave it to the last. That's always my habit. Okay, leave the most difficult to the last. Okay, we still have some points, okay, earned, okay, during the process already, even if we couldn't figure out. Okay, so give me an expression for, okay, now here, this is the L, right? You draw it here. L has two parts. Okay, let me see if I can use colors on my pen. I probably can. You have two lenses, the green the blue. Is my drawing good? Is that L? Okay. So at least you can combine these two parts. Let's say I give another letter here for my equation. I need to write down the equation. I need to show everything to Dr. Zhang so he can give me points. Okay, let's say I put the letter here D, representing the second portion. Okay, so the total length L is what? D plus something, right? D plus what?
2.5.
2.5, okay. You might get a point on just writing down this. Okay, that tell me you know how to separate this distance L into two parts. One part at least you know. Okay, so what is a D? Let me turn to the previous slides here. Okay, this is the equation YCP. Okay, so YCP equation. If I rewrite this equation into this, I move the Y bar to the left-hand side. What does it look like? YCP minus Y bar equals to I bar divided by Y bar times A. What's so funny? There's somebody laughing in the background. Okay, is that right? That's the same equation, right? So look at this drawing. This is the YCP, okay. Where is Y bar? I also put it down here, Y bar, right? Okay, I can also use colorful pens here. Let's say this is, the green one is Y bar. Okay, and the blue one, the blue distance is YCP. Okay, I use thick colors. Okay, okay. So tell me, what is YCP minus Y bar on this drawing?
D.
That's the D. That's just your distance. That's the D in our case. That's the difference between YCP and the Y bar, the center of pressure and the center of the area. The distance between these 2 points. We use D, actually is YCP minus Y bar, actually is I bar divided by Y bar times A. Okay, does that make sense? Everybody? That D, the difference between the 2 points is really, really important. So we can simplify the problem. We don't worry about from the water surface anymore. Hey, we know the difference. So D, hey, that's exactly what we want here in our case, right? So what? I can just use this to replace D, right? This is the D. Is that right? I bar divided by Y bar times area. Let me memorize it and put back to my paper. Okay, so this is my D, okay? I bar divided by Y bar times area plus 2.5. Okay, okay. Great. I feel even better now. Okay, so now to find out L, we just need to know this. What is I bar? What is Y bar? What is A? Okay. Easy thing first. What is Y bar? What is A? A already we did. 5 pi is A. Right? It's the area. Everybody, do you follow me? Please follow me. This is, we'll have
Yes,
just 10 minutes to go. Please just concentrate for 10 more minutes. Okay. Now we need to know a Y bar. Put down everything you know in there. Okay, 2.5, that's what I know. But Y bar kind of like become tricky. Let's look at the I bar. Okay, what is I bar? Okay, I need the expression now. So turn on that paper I sent you. Turn on that image, the shapes. For elliptical shape, it's there, right? It says pi times a to the cube, a to the power 3. What is a in our case? 2.5, okay? A and B are the times B is 2, divided by 4. Okay, everything is known in I. I is simple, okay? Every time you see an I is easy, okay? So only thing here I'm not sure is Y bar. Okay, now this problem will turn out to be just to find out what is I bar. You see, did you see the beauty of this process I'm writing down? It always leads you to find the next thing, next goal. Okay, you're never lost. Okay, if you can follow this engineering problem solving process, you never lost yourself. Okay, you're in it always. Okay, now you say, hey, I'm just trying to find out what is I bar. That's my last sticky point in this problem. If I find out Y bar, I solved for L, then I have FH and FL and L, then I can go back to the main equation to find out the force required F. Solve the problem. Problem solved. I said this is a complicated problem, but with the engineering process, no problem is complicated problem. Okay, everybody follow me? So now we need to find out the actual Y bar. It's not a 2.5. Again, it's not a 2.5. It's from this location to the surface of water. Okay, that distance is the Y bar. Okay, so our last obstacle is to find out Y bar. Okay, anybody have some idea how to find out Y bar? Okay, if you leave here, if I really struggle, I have no time, the test is, the final exam is over, almost over. I don't want to do this. I just stop here and I go, bye-bye. You probably get 21 or 22 out of 30. Or maybe got a 20 out of 25, I'm sorry. Okay, if you get a 20 out of 25 for every problem, you're okay. You know, you need a little bit of trigonometry here to find out Y bar. But if you really forget everything you learn in high school, that doesn't matter. You get 20 out of 25. Okay, I take it. Okay, so every problem get a 20 out of 25. You will score 80 out of 100 in my final exam. You can ask your former classmate, if you score 80 out of 100 in a final exam in Dr. Zhang's class, what grade he will get. Okay, there will be no doubt in A. Okay, so Y bar. Any idea?
Pythagoras theorem.
Huh?
Pythagoras theorem.
Find out how to find out the distance. Use a very, it need a geometry, right? In high school geometry, did you learn the triangle before, right triangle?
Pythagorean.
3, 4, 5, right triangle, remember? Okay, let me use other color. Okay, after I draw it, probably you can figure out. I have 2 triangles in this case. One I use green color, one I use blue color to draw. Okay. What's the relation between these two triangles?
They are similar.
They are similar triangles. Okay. You remember this similar triangle? Did you take geometry? At least one geometry, right? In high school, supposedly. Okay. 3, 4, 5. This green triangle is they are similar triangles. Okay. How about the green triangle? Is that 3, 4, 5 triangle? Is it?
Yeah.
Yeah.
3, 4, 5 triangle, right? 5, 4. You know the other side is 3. 3, 4, 5 triangles. Okay. So is the blue triangle also 3, 4, 5 triangle?
Yes.
Yes.
Yes, similar. So 3, 4, 5 triangle. Okay, good. And I know this side is 10. Let me switch back to blue color. I know this side is 10. In a 3, 4, 5 triangle, can you figure out the longer side? What is the length? Ratio, right? Symmetric.
The hypotenuse is 5/4, or actually,
Is this
5/4 times 10.
Yeah, yeah. It's
And,
this
the
is
other side is
this is
3/4.
the fourth side. The 10 meter is the fourth side of a 3, 4, 5 triangle. So it's 10. It's the fourth side, right? And the longest side I don't know which is the Y bar, which is
So
the
Y bar
5 side.
12.5.
Yeah, yeah, yeah. So Y bar turned out to be Y bar is 12.5 meter based on this ratio, right? So this is the 3, 4, 5 triangle. If you know one side, you know every side. Okay, so we solved the problem. 12.5 meter is the Y bar in this case. Okay, if you want to score 25 out of 25, then you need to dig into a little bit geometry, trigonometry, those kind of stuff. Okay. But there's no excuse to not score 20 out of 25 for this problem. Okay. Everybody? Any questions? Okay, so I get my, what is my L actually? Do I have a value? You want to calculate it? Is 2.625. Okay. Who's talking?
Yo, Mika, you're unmuted.
Let me unmute everybody. I just don't want to unmute everybody. Could you unmute yourself?
I think he might have walked away.
Yeah, so that's why I need to have a test quizzes all the time during the class, so everybody, you know, still pay attention, listening. Okay, I muted him. Go back. Let me go back to my screen. Let me give you the final answer. So I'm out of space here. Can I use the next page? Okay. So my L is 2.625 meter. Okay. My FH is 1.54 times 10 to the 6 Newton. So my F value calculated 800,000 something. Let me see.
809 kilonewtons.
Yeah, 809,000. I don't like kilonewton because directly from your calculation is Newton. Okay, kilonewton is a conversion, right? So the number you key in your calculator, it will be 809000. The result from the number you key in calculator, it will be like this. So this is the force required to open this gate. Okay. Oh. Okay. So this is the entire problem. Okay. Did you see that? This again, let me say this. This is a difficult problem. Okay. even just in the class, you know, difficulty wise, it is a difficult problem for statics, hydrostatics. Okay. But I'm trying to give you a way to solve difficult engineering problems, which we can follow then and lead you to the answer. Okay. Then when you go back look at it, it's really not difficult if I can stick with the correct process. That's the difference between an engineer and a regular people. Okay, it's not the material, not the knowledge, the content you learn in the class, but the way you think. Okay, the way you solving problems. Okay, so eventually, I want to make you feel this problem when you go back. Okay, it's not that bad. Okay. Any questions before we leave? I have a couple minutes here if you have questions. So far, so good. So I will assign a set of homework problems, including this topic, as well as the last topic of chapter 3, which is buoyancy. I will assign all together. You don't have to do the buoyancy problem yet, okay? So, but start to practice the surface force calculation, okay? So I guess that's it for today.
Thank you.
You're welcome. See you today, Tuesday. See you Thursday.
Wait, did you say you're going to post some homework or not? Or
I'm
you're
going
not?
to post the homework today. So
Okay,
you have some
post it
time.
on
Oh, when will the projects be graded?
Project will be great. Take a while. The video, you know, and I watch everybody's video 4 minutes, 5 minutes. Then you know we have 20 people here, so it's already about 2 hours. So it takes a little bit time for me to watch it and grade it. But
Hopefully,
I'm trying to get it.
Hopefully, you're pretty kind on this one because there was definitely a learning curve.
Yeah.
First, I was worried about making 2 minutes. My first draft was like 10 minutes, so I had to just edit it. And
You have a lot to say. Good. Yeah.
I don't think I didn't. I guess I didn't know how to plan it on paper, how the amount of time, and when I did what I planned,
okay,
it was. I mean, I edited the hell out of it, so it's not what I originally.
Okay. See, this is a learning process for everybody. It's good. Okay. Yeah. So I will. Yeah, you're right. I probably will grade the first video more generous than the later videos because that's your first time doing it. Okay, I agree.
And then also, if it was too big, we can put it in the comments, the link to it.
If the file is too big, can you post it to like YouTube and then send me the just.
Yeah. That's what I did. I just sent you the link in the comments.
Yeah. That's what I prefer. You don't need to upload the entire video. The video, I know it's very big sometimes. Yeah. Okay. So I hope I can get you grade the video before the next video project due. Okay. So you have some feedback from me for you to prepare the next one. Okay.
All right. Thanks.
You're welcome. See you later.